In this video, we're going to go over the different types of waves that exist. We have transverse waves that go up and down. We have longitudinal waves that kind of compress the medium together and then have places where it's more spread out. And then we have combination waves that a combination of those two things happen. So in transverse waves, I'm going to go ahead and draw us an image of one here. Everything moves up and down. And I can show you this in a simulation where it's moving a little bit. In transverse waves, you can see individual particles will move up and down. And you can follow those top parts across the screen. And you can see they move to the right. Same thing with one of the bottom parts. You can follow that across the screen and it's going to move to the right. But an individual particle moves up and down. So I can see that bigger particle, the big red one, is going to move up and down, even though it looks like the crests of those waves are moving across the screen sideways. So that's characteristic of a transverse wave. When we draw those up and down, we call those top parts the crests, like the crest of a hill or a mountain. We call those bottom parts the trough, like a feeding trough. Looks kind of like that. Animals would eat out of. And then if we pick any given particle, like we picked that big red one in the illustration, it's going to move up and down. While if you pick a crest while it's moving, it's going to move side to side. So that's what my energy arrow at the bottom is. That's energy transferred. Okay, so that's a transverse wave, one of the three types. A longitudinal wave, I like to, instead of drawing like a single line, I like to draw a bunch of lines all together. So we have places where that's more spread out, and then we have places where that's closer together. And we have places where it's spread out, and places where it's closer together. And we'll just repeat that pattern across. You can use lots of different ways to illustrate that, but I think drawing the lines is the easiest way. So just like that. We have some different words that we'll use. We can call those parts that those are compressions. So if we move over back to our wave simulation and we change that to longitudinal, now I can see those dots compressed together and I can follow that compression across the screen the same way I followed a crest across the screen. And then I can trace the path. And in this case, instead of the particles moving up and down and up and down, here they're moving parallel in the same way that the compressions are moving across the screen, back and forth and back and forth. So longitudinal waves, the oscillations happen in a parallel direction to the energy transfer. So we have energy transfer again at the bottom. You can see that in the illustration. Those parts that are bunched together, we call those compressions. Those would be like the analog to the crest on a transverse wave, compressions. We have parts at the bottom. I'm going to call those rarefactions. Sometimes you'll see websites or different sources call them expansions, and that's not wrong. It's just two different words that mean the same thing. So rarefactions, places, rare means something is, there's less of that. So there's less stuff in the rarefaction areas. And if we pick a given point, again, it's going to oscillate back and forth and move in the same direction that the energy transfer is happening. So on that same plane in a parallel way. The last type that we have are called combination waves, and sometimes they're also referred to as surface waves. Your textbook calls them surface waves, and we also have the simulation that we're going to go to calls them surface waves. But the way that I like to draw those looks a lot like a wave at the surface of the ocean. The way that like we learned how to draw waves when we were really little and starting to color and draw things. We use some of those same words. We call the top part the crests. We call the bottom parts the troughs still. But here, we're going to have a combination of those movements. So going back to the simulation, we'll change it to surface. And you can see from the picture, the path is going to be actually circular. So the wave shape looks a lot different than if the movement of that looks a lot different than like one given point. It's going to move kind of in a circle. And it doesn't necessarily have to be a perfect circle. Sometimes it's an oval where the top up and down motion's bigger or the side to side motion's bigger. But it's going to have a combination of those up and down and side to side movements. So we call those surface waves. And their oscillations look like a circle. Just like that. But the energy transfer is happening in that same direction as the other examples. So if I go back to the illustration and I track one of my crests across the screen, it's still moving across, but my particles are moving side to side. And those are the three different types of waves. Just to review, we have transverse waves that move perpendicular to the energy. We have longitudinal waves that move parallel to the energy. And we have surface or combination waves that move in a circular path, and they have up and down and side to side movements. Transverse, longitudinal, and combination. Those are your three types of waves.